Good morning. I am Dr. Johnson SAVARIMUTHU, Assistant Professor, PG and Research Department of Mathematics, St.Joseph College, Cuddalore. We talk about mechanical system. Equation of motion. F is a force, V is the velocity, A is called acceleration, P is called linear momentum, M is mass. By Newton's law, second law, P equal to mv, F equal to mass into acceleration. We can write m acceleration dv by dt, d by dt of mv, therefore dp by dt, F equal to dp by dt. If F is equal to force equal to 0 and integrating on both sides, then integral of dp by dt equal to 0, p is constant. Hence the total force acting on the particle is constant. Therefore the linear momentum is constant. If you consider the motion of a system of particles, then the total force acting on the particle can be divided into two groups. One, external force and a force of constraint acting on a particle from outside, and it is denoted by Fi vector. Force of constraint, therefore it will be condition. Internal force acting on the either particle due to all other particles, that is Ri. Further acceleration equal to Ri double dot. By Newton's second law, we can write mi Ri double dot equal to Fi plus Ri. We can consider r vector equal to xi vector plus yj vector zk vector. R dot equal to x dot I vector plus y dot j vector plus z dot k vector. R double dot equal to x double dot I vector plus y double dot j vector plus z double dot k vector. Fi vector equal to Fi xi vector plus Fi yj vector plus Fi zk vector. Ri vector equal to Rix I vector, Ri yj vector, Ri zk vector. We can write mi of x double dot I vector plus y double dot j vector, z double dot k vector equal to Fi of xi vector plus Fi of yj vector plus Fi of zk vector plus Rix I vector, Ri yj vector, Ri zk vector. We can write Fi plus Rixi plus Fi plus Ri yj vector plus Fi Ri zk vector. We can write Fix Rix I vector plus Fiy plus Riy j vector plus Fiz Ri zk vector, equating ith jth component. Therefore the coordinates are mi x double dot equal to Fi of x plus Ri of x, mi y double dot Fi of y plus Ri of y, mi z double dot equal to Fi of z plus Ri z. We can put I equal to 1, m1 x double dot f1 of x plus r1 x, m1 y double dot f1 y plus r1 y, m z double dot f1 z plus r1 z. Let us denote the Cartesian coordinate of the first particle. First x1, x2, x3, second particle x4, x5, xx, therefore the etc. kth particle x3k minus 2, x3k minus 1, x3k. Then the equation of motion mi Ri double dot equal to Fi plus Ri, I equal to 1 to 3n. We can define degrees of freedom. The number of coordinates required to specify the position of the system is called degrees of freedom. We can see the example. To find fix 3 points in the space required 3 quantities: A of x1, x2, x3, B of x4, x5, x6, C of x7, x8, x9. Then the quantity are connected by the relation AB square equal to C1 square, BC square equal to C2 square, CA square equal to C3 square. C1 square x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z whole square. And hence the number of degrees of freedom equal to 9 minus 3 equal to 6. Generalized coordinates. There will be minimum number of independent coordinates needed to specify the motion. These coordinates are denoted by q1, q2, etc. qn is n generalized coordinate if your system has Cartesian coordinates x1, x2, etc. x3n. x1 equal to x1 of q1, comma q2, etc. qn, etc. x3n equal to x3n of q1, comma q2, etc. qn. In general, xj equal to xj of q1, q2, etc. qn. xj equal to xj of q1, q2, etc. qn, comma t. dxj divided by dt, dou xi divided by dou qi into dou q1 divided by dou t, etc. Dou xj divided by dou t into dt by dt. Therefore, the virtual displacement del xj equal to I equal to 1 to n dou xj divided by dou qi del qi plus dou xj divided by dou t del t, since the virtual displacement del t equal to 0. Configuration space. Let a system of n particles have n independent generalized coordinates q1, q2, etc. qn. It is convenient to think of this n number of as the coordinates of a single point in a n-dimensional space is called configuration space. Constraint which limits the motion of the system or the limitation imposed on the motion of the system are called constraint. First, we define holonomic constraint. Suppose the configuration of the system is specified by n generalized coordinates q1, q2, etc. qn. Assume that there are k independent equations of the constraint is of the form phi j equal to q1, q2, etc. qn, comma t equal to 0. A constraint which can be expressed in the form is known as holonomic constraint. Non-holonomic constraint. A constraint that are not expressed in the above form are known as non-holonomic constraint. Scalenomic constraint. Constraint in which the limit t does not appear is called scalenomic constraint. Rheonomic constraint. Constraint in which the time does appear is called rheonic constraint. Virtual displacement. Virtual displacement is the displacement which assumed to be occur without the passage of time. Suppose t is constant, then dt equal to 0. Actual displacement we can write dx dy. Virtual displacement del x, del y, etc. Virtual velocity. The rate of change of virtual displacement is called virtual velocity. The ratio del x divided by del t, which has the direction of velocity, is defined as virtual velocity. In general, virtual velocity is not actual velocity. Actual work done W equal to F dot dr. Thank you.